of this a symbol on a periodic table. So you have some element, and this is the symbol for an element, and then you'll have the atomic number and the mass over here, so like 1.007. This is going to be your mass, and this is going to be your atomic number. Another way to write that, did you guys talk about like you have X, and then you have A, and Z, and like P, some letters like that? No, nothing at all? Was the chemistry chapter 2? Or on other periodic tables like the one in your book, they have the atom symbol and then the atomic number and the mass on the bottom. So essentially what this atomic number means is this atomic number is the number of protons. Like, and that's all the time. Like if you have one proton, you're always going to be hydrogen. If you have 2 protons, you're always going to be helium, and so forth and so on. And then the thing with atomic mass, though, is atomic mass can change. So if I have this, there are other isotopes of hydrogen that have. Do you guys talk about isotopes?
Yeah, we did.
So what's an isotope? Exactly. So an isotope differs in differing number of neutrons and has different weights. So you can have, say, like carbon-12 or carbon-14. So there are a couple different isotopes of carbon, carbon-12 and carbon-14. Carbon-12 is going to have, it's whiter, so the 12 represents, the 12 is going to represent the sum of the protons and the neutrons. So in this case, it's going to have, carbon has 6 protons. So in this one, it's going to have 6 protons and 6 neutrons. And in this one, it's heavier. It can't have any more protons, because to be carbon, you have 6 protons, period. Like, that's what you have.
So that element, or carbon-12, if you look at the specs on it, the atomic number is still 6.
Yes.
And the atomic mass is 12.
Exactly.
Why is the mass in the upper right-hand corner of the element split from, like, for instance, carbon, regular carbon is split between 2 and 4 over there?
Don't
All of these are they're split, and I don't know if that's.
don't worry about those numbers right now.
Is that the electron maybe? No, I should be doing
it's a lot more in depth for what you guys
What
need
is the
for
atomic?
atomic mass of carbon. Is going to be the number on the bottom, so it's going to be 12.011. So on a periodic table, on the bottom, it'll have the number of 12.011. And with that, question?
Can you explain how isotopes form? Like, you said they could give out their protons.
So that happens through radiation and radioactive decay and stuff. Let me go through like isotopes and stuff, and then I'll go to decay, because decay is like another big topic. Anyway, so isotopes are, so on those periodic tables, if I say you have 8 protons, then what atom are you? Oxygen. And if I said like 32? Germanium, right? So essentially just know that. So if you have whatever the atomic number is exactly. these are just two isotopes that I know exist of carbon. So in this case, he's going to have 6 protons, and how many neutrons is he going to have? 8 neutrons. So just know that for isotopes, differing number of neutrons. And then what about, do you guys talk about ions? No, not at all. So what an ion is just, it's when it has differing number of electrons. So even though a normal carbon atom will have six electrons around it, but say I took let me use fluorine. So fluorine will have, do you guys talk about valence electrons at all? No? Okay. Let's not worry about that. Okay. Do you guys talk about bonding?
Yeah.
Okay, so what are the different, let's talk about that. What are the different types of bonding? So there's covalent bonds. What other kind of bonds? Ionic bonds. What else? Huh? Covalent.
Compound?
Compound?
No. Is that right?
Well, they're not really.
Okay. I don't know the answer you're looking for then.
Let me see if there's a chart. So the only other bonds that are kind of important, do you guys talk about hydrogen bonds at all? No, hydrogen bonds. Okay, let's just do covalent and ionic though. Then. So what's a covalent bond? Not quite. What did you say? Transfer, not quite. Shared, good. So when you think covalent, think sharing. So in a covalent molecule, like if like 2 carbons were bonded to each other, that would be a covalent bond. So bonds between like two nonmetals. Ionic bonds. What are ionic bonds? Huh?
One atom gives an
Transfer. Yeah, so think transfer and giving electrons. So what's going to happen in that case is you're going to have something like in salt, you're going to have Na plus and F minus, and because these opposites attract, right, for charges?
So when you're sharing and transfer, you're talking about
Electrons.
Okay.
Always think what causes bonding is electrons. Protons don't really have anything to do with bonding. It's all about the electrons. So what this represents is that these 2 atoms are sharing some electrons, or 2 electrons in this case. And in this example, this one took an electron from this one, and now because there's a positive and a negative charge here, these 2 things are going to be like this because positives and negatives attract. Like magnets, right? Like you guys have messed with like magnets, like like if you put 2 positives ends, they don't want to go together, but positive and negative end will go together. What else on chemistry that's confusing? Radioactive decay. Let's do that. Was that chapter 2? Do you know, or is that another chapter? Isotopes and radioactive decay.
34, like halfway.
Page 34. Do you guys talk about metallic bonds at all?
No.
Okay, don't worry about that then.